This section, we're going to talk about what makes a function. So starting off, what's a relation? A relation is any set of ordered pairs. So basically, anything that can be graphed is a relation. The first component of the ordered pair is the domain. So that means the domain are the x values, and the second components are the range. That means the range is the y values. So name the domain and range here. When we do this, we want to make sure that our numbers are in order, and we start and end our list with braces. So the domain are the x values. So we've got 0, 10, 20, 30, and 40. Those are in order, so we're going to go ahead and list them here. Close it with the brace. And then the range is our list of the y values. We want to put them in order again, so we need to start with 6.7, then 9.1, 10.7, 13.2, and 21.2. A function is a correspondence from a first set to the second set, such that each element in the domain corresponds to exactly one element in the range. Okay, what does this mean simply? This means that no x values can be repeated. Okay, so make a note of that on your notes. No x values can be repeated. So if we look at these two, we can see if we look at the x values of the first one, 1, 3, 6, and 8, they're all different. So that means that this graph is a function. If we look at the x values of part B, 2, 2, and 3, 2 is repeated, which means we do not have a function. If an equation is solved for y and more than one value of y can be obtained, then the equation does not qualify as a function of x. So let's look at an example of what I'm talking about here. Determine whether the equation defines y as a function of x. So solve it for y is the first step. Subtract x squared from both sides. And take the square root of both sides. When we do that, we have a plus or minus. The plus or minus means that we could have more than one x value for the y value. So therefore, this is not a function. Function notation. Let's say we have a graph that says y equals x plus 2. Okay? Function notation is just rewriting this with an f of x in place of the y. F of x and y are the same thing. Okay? So either way you see it written, it means the same thing. But we write it as f of x just to help us when looking at different problems. Okay? That is the function notation. And f of x, what that means is, what is the y value when x is whatever? Okay? That's what that means. So looking at an example, f of negative 5 means what is the y value when x is negative 5? So to solve this, we plug in negative 5 for x. Make sure here when you're squaring x, you're squaring all of negative 5. So you have to make sure that that negative 5 is in parentheses, because negative 5 quantity squared is negative 5 times negative 5, which is positive 25. Big deal. Negative 2 times negative 5 is 10. Add those together and we get 42. So what this means, again, is when the x value is negative 5, the y value is 42. So the point negative 5, 42 would be on this graph. Here, we're finding f of 3a. Well, I realize that you wouldn't have an x value of 3a, but this prepares us for things in the future. So to find f of 3a, that's where the x value is 3a. We plug in 3a for x. Again, we are squaring all of 3a, so make sure you put that in parentheses. 3a squared is 3a times 3a, which is 9a squared. 2 times 3a is 6a plus 7, and that's as far as we can go with that. It's okay that we didn't end up with an integer, with a number. That's as far as we can go. That's your solution. For this one, what is, when we plug in x of 4 plus z? So again, make sure that 4 plus z is in parentheses because we're squaring all of it. Make sure it's in parentheses here because we're distributing the negative 2 to both the 4 and the z. So 4 plus z squared, remember that's the same thing as 4 plus z times 4 plus z. I won't always write that out on the notes, but I will for now. So you would FOIL this. First, 4 times 4 is 16. Outer, 4 times z is 4z. Inner, z times 4 is 4z. Last, z times z is z squared. Then going back up to negative 2 times 4 plus z, distribute the negative 2. So negative 2 times 4 is negative 8. Negative 2 times z is negative 2z. I'll go ahead and tag that on down here. Combine our like terms. So we've got a 4z, and a negative 2z. We've got just one z squared. So I'm going to start with the z squared. I then combine our z's. 4z plus 4z is 8z minus 2z. That gives us 6z. And then we have 16 minus 8 plus 7. So 16 minus 8 is 8. And 8 plus 7 is 15. Okay? The graph of a function. It's the graph of its ordered pairs. So for example 5, it wants us to graph the function 2x and 2x minus 3 in the same rectangular coordinate system. So let's do that. 2x. We're just going to pick x values and plug them in and figure out what we get for the y. So 2 times x. 2 times negative 2 is negative 4. 2 times negative 1 is negative 2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. So if we graph this, we've got negative 2, negative 4, negative 1, negative 2, 0, 0, 1, 2, and 2, 4. And so this function is a line that looks like this. The second one, g of x, is equal to 2x minus 3. So we plug in our x values again. 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. 2 times 0 is 0. 0 minus 3 is negative 3. 2 times 1 is 2. 2 minus 3 is negative 1. And 2 times 2 is 4. 4 minus 3 is 1. And so we graph these. The first one we can't fit on our graph. That's okay. Then we've got negative 1, negative 5. 0, negative 3. 1, negative 1. And 2, 1. And so we've got another line. There is g of x. Next, how do you look at a graph and determine different things from the graph? Okay, how do you determine the domain and range from the graph? Well, again, still the domain and range, the domain are still the x values and the range are still the y values. So if we look at this graph and we want to determine the domain, then you're going to start with the x value of negative 2 and go to an x value of 1. Notice these dots here are solid dots. So that means that we are including them. So in interval notation, the domain is from negative 2 to 1. And we use brackets because that is including the x value of negative 2 and of 1 because of those solid dots. Then the range are the y values. So starting from the bottom, moving up, we are starting with a y value of 0 and moving up to a y value of 3. Again, because of the solid dots, they're included. So we've got bracket, 0, 3, close bracket. For example, 7, the domain, again, are the x values. Start with the left, move to the right. So here we're starting with negative 2 and moving to the right to 1. Except in this case, at the negative 2, there's an open dot. So what we have to do is we have a parenthesis before the negative 2, and then there's a closed dot where we're at 1, so a bracket there. And then the y values start at negative 1 and go up to 2. So we're including the negative 1 because that's a closed dot. So bracket, negative 1. Since the 2 is at an open dot, we use a parenthesis after it. And then, how do you find x and y intercepts from a graph? We've done this before, kind of. Okay, so identify the x and y intercepts for this graph. The x-intercepts are where it crosses the x-axis. So here's one at negative 3, 0. Here's another one at negative 1, 0. And then the last is over here at 2, 0. And then what is the y-intercept? It crosses down here at negative 6. So the y-intercept would be at the point 0, negative 6. That concludes this section.